Okay guys, we got a real good one here today. This is a 2005 Honda Element with a 2.4 liter engine. History with the vehicle: this was brought into the school for an engine replacement, and our engine class replaced the engine, and it is now a no start. I was told that it did run when it came in, and with this engine swap we now have a no start situation. Let me take a moment to talk about direction here and where you start. I think one of the difficult things as I continue to film these different case studies is where to take you, where to start, and I don't think there really is one right way to do this. We can go scan tool first, we can look for codes, we could right away look for spark, the coils are easily accessible, we could look at fuel pressure. There's a lot of different directions that we can take. So again, just want to emphasize that my approach is probably different for every car I work on. It just depends on the car, the symptoms, the situation, and what components are accessible and which are not, as far as direction and where to start. So I think for you guys, for this video, I'm going to take you to the scan tool first, and we're going to see if we can communicate with it and get trouble codes out of it. Okay, so I already have my vehicle identified, 2005 Honda Element. I'm going to select engine, and I have the right adapter and chip already installed, and we're going to go codes, hoping for some guidance here with a trouble code. You know, maybe things were left unplugged, who knows. And what we find is we have a no communication with the engine computer. So definitely something could have been left unplugged, maybe a main power, a main ground. In particular, the grounds, remember the engine was swapped out. Let's see if this data link connector is actually functional, and we'll try talking to a different module. What I've found when we have no communication problems, typically what I do is I will check pin 16 for a power, and what you'll find most of the time, at least here at the school, what I find is that either A student has misidentified the vehicle, or B, we have no power on pin 16. So this is one of the ways that we can address that, is to see if it talks to other modules. So we'll go to the transmission, see if we can talk to the TCM, same thing, looking for trouble codes. And I have no communication there too. So I'm going to exit, go back to our ABS. And you see we have some ABS code. So what that tells me is most likely pin 16 has power, and we're talking on this network. So I'm not concerned about a data link problem in this case, or a misidentified vehicle. I am definitely worried about engine and transmission and why these aren't talking to us. So we're going to move now away from the scan tool and away from the data link connector, and we're going to go toward main powers and grounds at this engine computer. Remember, this thing just had an engine replaced, so of course the grounds are a big concern here. Alright, I brought you inside the car. Before we do computer powers and ground testing, there's a few other things we can do. One is to take note of our check engine light, see if it's lit, and it is. Turn key off, key back on. Our check engine light is lit. We do have an anti-theft light, or a key light, that's blinking on and off, so we'll take note of that too. Could be an anti-theft problem. I'm going to crank it so you can hear it. So you hear it is a no start. We're not sure what we're missing yet. We haven't checked any of that. I'm concerned about a no communication issue though, combined with a no start. That's a big time problem. So before we do powers and grounds, I'm going to give you one more check under the hood that's easy to do, and that is to check the 5-volt reference circuit. So we're going to go back under the hood. Alright, before I do this reference test, I want to talk about when I want to do this. You know, sometimes we can have vehicles that come in with a no communication problem, and it has nothing to do with the engine performance issue. You know, we can have a blown fuse to the data link connector and we have no communication with the scan tool and the car still runs. So same thing with a no start. Is our no start tied in with the no communication problem or not? And I think this test addresses that. Check for a 5-volt reference on one of the sensors, and what that does is tells you whether or not the computer is alive and talking to you. So I generally choose the TPS because it's an easy location to do a test, and I'll get you a shot of where I'm connected. So I have you zoomed in on the TPS right now, kind of a shot through this area in front of the grill. You can kind of see where I'm connected. And I don't have a wiring diagram yet, and you don't need one. If you know these fundamental principles of how a potentiometer works, we know that one of the 3 wires on this 3-wire potentiometer is going to have 5 volts on it. So that's universal across the board on any year, make, and model car, although there are some variables on some of the older cars that use switch inputs for the throttle. That is not the case on this car. So what I'm going to do is just move the T-pin down the line and take measurements on all 3 wires. So I'll take a measurement on this one, and then I'll move it down to the next 2 in succession. And what I will do is have you focused up on the scope while I'm doing that, and we'll see the result of this test. Okay, I'm set up on a 2-second screen, 10-volt scale, just personal preference. I'll get you a reading on this first wire. And this will be, well, wire color really doesn't matter. We don't have a diagram, so 0.02, potentially a sensor ground. Move to the next wire. Again, we're just looking for 5 volts here. We're not really worried about the TPS signal. We are worried about our 5-volt reference and really our ground. It looked like we had a good sensor ground. There's a reading of 1.5 volts on that wire. That looks a little high for a signal wire at idle. And we'll go to the next pin, and we're reading 1.7 volts. So here's what we know right away with where we are with this vehicle. We have a 5-volt reference circuit problem. The computer should be sending 5 on one of these 3 wires, and it's not. So again, I didn't know exactly which one was the 5-volt reference wire, but I know for sure that one of them should be 5, and we don't have that. So here's the direction change up now. If you were doing a no start, you'd check for spark, check for fuel, check for compression, and all of that stuff where we are right now, we don't need to do. I'm not going to bother checking for spark. I'm not going to bother checking for injection pulse or fuel pressure or compression for that matter. I need to fix this 5-volt reference circuit. This is a main lifeline for this computer system. If this reference circuit is shorted, it's going to pull everything down, including a communication issue with the scan tool. Now, most of the time, it would also kill the check engine light if that was the case, but not always. So I think before we would pull a diagram and find out all the sensors that share this 5-volt reference, I think the next step would be powers and grounds, because it's the most common issue. You have low voltage or no reference voltage. Generally what you have is a power or ground problem on that system. But we definitely have a reference circuit issue. We're on the right path. Powers and grounds are coming next. And again, I'm looking to shortcut this. And what I've done so far is pulled a diagram, marked them up, and I'll show you that in a second. But my main concern in this diagram was to show you guys the computer grounds. Let me get you a shot on the block here where these computer grounds are. They're right here in this location. And according to the wiring diagram, there are 4 main grounds that are coming from the engine computer, and those colors right there match my diagram. So we can actually do a ground check right there. And I've shown this before. The last vehicle that we had, I think it was a Toyota Echo that had an issue, and I think that vehicle ran, but it had bad computer grounds, if you guys remember from that video, and it had to do with a salvage yard engine that this aluminum housing oxidizes, and then you bolt the eyelet onto an oxidized housing and you have a bad ground. So can we quickly identify this ground connection without taking the bolt off and cleaning it up? The answer is yes. It's very simple. Just take your lead you were using for your previous test and connect it to the eyelet, not on the housing, but I'm back away from the housing, away from the bolt, and get a voltage reading right there. If this ground is bad, this voltage right here will be elevated. So I am connected to that right now. The key is still on, and let me get you a shot on the scope. And I basically have 0 volts on that location. So that is not a bad ground. Our suspicions of the engine being replaced and somebody leaving a ground off are probably not the case. I could shortcut this for you guys, but I think it's important to do the process, and the process next is going to be go to the computer and check your powers and grounds directly at the computer. Well, that would be one direction. The second direction that you would have to go is to locate all of the sensors that share the 5-volt reference circuit and start unplugging them. But playing our odds here, we're going to go computer powers and grounds first, because most of the time that's where your problem lies. So go into the computer next. This is where it helps to have a good wiring diagram. This is a Mitchell on-demand wiring diagram, so thank you to Mitchell for these great diagrams that help us aftermarket guys tremendously. The reason I like them so much more than the other ones is Mitchell redraws them and makes them all look the same format, so I don't have to learn how to read legends and codes to read a wiring diagram on, say, a Honda compared to a GM. They look exactly the same to me. Definitely helps us aftermarket guys to have this style of wiring diagram. And what I've done already is I've mapped out my ignition positive feeds right here, the 2 pinks I have in a pink highlighter, and then my 4 main grounds. So we're going to check those grounds, we're going to check these 2 feeds, and then there's one more. This is kind of a split diagram. There's one more right here, an ignition positive feed. So I have 3 main power feeds and I have 4 main grounds. I'm going to go inside to where the computer is now and check those locations and give you guys some numbers on that. Here's a shot of the back of the computer. We're in the glove box area, and one of the difficult parts about finding computer powers and grounds and matching them up to your diagram is pin location. And there are definitely some helpful charts that give you pin numbers that we can compare the backs of the connectors and get numbers and then compare that to colors. But what I've found to be very helpful is to look at sequencing. So what I want to do is look at my wiring diagram, starting with this top area here, and we're looking for sequencing. You can see A1 is white, A2 and 3 yellow, black. So they're, in numerical order. So we're looking for white, 2 yellow blacks, and 2 blacks, looking for that in sequence on the connector. And we can actually see that. We go back in here and look down at this bottom connector, and you see that we indeed have a white, 2 yellow blacks, and 2 blacks. And I'll read off the diagram here for the next couple, see if we're on the right part of the connector. The next wire color would be green, and then we have a yellow, and then after that we have brown and yellow. So right up this side of this connector is where I'm going to do my first checks. I'm going to check those first 2 yellow blacks on pins 2 and 3. Those are power feeds. And then I'm going to check the 2 blacks. Those are grounds. And then I'll go a little further up and check the brown and yellows at the top. Those are also grounds. So I'll be able to knock off all 4 grounds and 2 of the power feeds on this one connector. Take a second here to talk about another variable. We are inside the car now, and we're going to do some power and ground checks. So it's really important that our ground location, where we've chosen our ground, and by the way, this dash was ripped apart when we got it. Looks like someone was doing some testing. But in any case, this metal bracket that I've chosen for a ground, it's metal, so you think it's a good ground, right? Well, we want to make sure. We don't want to guess, because the result of these numbers are going to change our direction and where we're going to go. So before we would ever check our computer grounds, what we want to do first, check one of the power feeds. And that'll kill two birds with one stone. One will be that'll let us know that we have a good power feed, and two, it'll also let us know that our ground selection is good. We don't want to do ground to ground voltage drop tests when we have a questionable ground on our multimeter. So check your power feed first. Make sure your meter reads 12 volts, which tells you your ground location is good, which is critical for further testing. All right, there's a shot of our first power feed. It's 12.26 volts. So that is good. Moving to the next one. Okay, you see I'm on the next yellow black wire up, pin 3. Quick comment on these computer pin connectors. Don't be real aggressive with this T-pin. Some of these connectors are very easily damaged by back probing with a T-pin. And then also, if you're not careful and you don't go straight in, you can cross feed one path into another, so you have to be very careful. So checking my next power feed wire. Okay, there's our second power feed. It's 12.26 volts. I'm going to do the 4 grounds on the same connector next. All right, I got the first black wire T-pinned. I'm going to hook to that one. Get you up to the scope, and I think what I'll do the rest of the way, rather than going back and forth, I'm just going to keep you on the scope. So I'll go with the first black wire, and then I'll go next to it is another black wire, and then I'll come up to the top of the connector up here where these brown and yellows are, and show you the scope reading on all 4 of these grounds. All right, here's the first of the 4 grounds. See, I'm reading negative 0.02. I'm not worried about a negative voltage. That just means my computer ground is actually better than the ground point I've chosen on my multimeter. Nothing wrong with that ground. Now, one of the things that you worry about is, are you even connected? Can we trust our voltmeter doing ground to ground voltage tests? Well, remember, the key is on, so it is a loaded circuit. That's critical. And then the other key with this would be to disconnect your lead from where you're connected. So I'm taking my yellow lead off, and you see all the noise that's in that pattern now that you didn't see a second ago. The other thing you can do is you can shake your lead, which kind of increases that noise. And then when you connect to the circuit, all that's going to go away. Watch, I'll connect back up to it again. So you see the difference between a good ground and a no connection is clearly visible. So that is a good ground. And to save some time here, guys, every single one of my grounds read this. So really, we have one more power feed to check, and then what we're going to say is all of our powers and grounds are good. So we did most of our power and ground checks down here at this bottom connector. My final power feed is all the way up here at the top. It's another black yellow wire. Get your reading on this one. Okay, and as you can see, we have 12 volts on that one as well. So we have all good powers and grounds on this vehicle. All right, next step in this process is we want to map out this 5-volt reference circuit. Being that our computer powers and grounds are good, our concern is that we have a short in this 5-volt reference. Being we have low voltage on our TPS at this location. So what I've done, I've already mapped this out, but I want to just share with you my thought process. We're looking at a 3-wire potentiometer right here, and a 3-wire potentiometer has a 5-volt reference signal and a ground, and certain things can be shared and certain things cannot be shared with potentiometers and thermistors. And the first thing would be we don't share grounds. You can see that this wire right here goes to a splice and is shared between these 2 thermistors, so I know for a fact that that's going to be my ground circuit. The signal is on the wiper, and so we know that this wire is the signal wire, and that means that this final wire is the reference. And you see a splice here that we share this reference with another sensor. So mapping this out, you see it comes over here and comes over to my main shaft speed sensor, which would be part of the automatic transmission. So the main shaft speed sensor and the TPS both share the same reference wire. That comes back to the computer, where I have this pink at this location right here. The computer coding, I can't even read it anymore, VC, I'm sorry, I drew right over top of that. It's not important for the coding. I think it's VCC2 VC is a common abbreviation, I know on Toyotas, for a 5-volt reference circuit, the VC circuit. All right, there's other sensors that use a reference though, and that would be our map sensor. So our map's gonna have a 5-volt ref, and I followed that one using the same principles, what can be shared, what cannot be shared. And you see that that map comes up to a splice up here, comes over to another piece on the transmission. This is my countershaft speed sensor. So both transmission speed sensors share a reference, one with the map, one with the TPS. And what looks like two separate reference circuits really is not. This comes back to the computer, and they come in two locations. And I've seen this on other cars. What you think is two separate 5-volt reference circuits is actually not. It is shared internally at the computer. So my next two checks are going to be to check both of these reference wires right at the computer. Back to our diagram again. We're on actually the same connector. We're looking for a yellow blue and a yellow red, and I actually found them using sequencing again. We're on the same connector that we were on when we did our power and ground checks. See if I can get you a shot on it. And the yellow red and yellow blue is right next to the two brown and yellows, which were my two grounds. Those are my 5-volt reference circuits. And if I am correct in what I'm saying, that these are shared and there's only actually one 5-volt reference, what we're going to find is the same voltage level on both wires. So I'm going to get you a shot of that next. All right, I changed the voltage scale so you can see it a little bit better. This is my first 5-volt reference wire. I'm reading 1.7 volts. That's the same wire we were at on the TPS. Now we know which one on the TPS was our reference. It was actually the yellow red. I'm going to drop down now to the yellow blue and get you a voltage reading on that one. So 1.701. All right, now here's the shot of the yellow with the blue, which is our other reference circuit, and it's the same exact number. So what we know for sure is that the computer is sourcing out two separate 5-volt reference circuits, but they are tied together internally. And what our suspicions are is one of these sensors that share this reference is shorted to ground, or we have a short to ground in the harness somewhere. This thing having an engine put in it, it could very well have a harness that's pinched. So our next process here is going to be to unplug these sensors one at a time and watch our 5-volt reference circuit as we do it. And hopefully when we find a shorted sensor, this 5-volt reference will return. And we're going to go into the hood now and start with the easy ones to get to. All right, I moved my multimeter lead back to the TPS under the hood. Just because I'm under here working, it's easier to watch this 5-volt reference circuit from outside. Remember that our red and yellow and our yellow and red and our yellow and blue are two separate 5-volt references, but they're shared internally, so it doesn't matter which one you go to. Pick one. I'm going to stay on the TPS because it's the easiest to do. And what I'm going to do is reach down and unplug the TPS first as I keep you focused on the meter. All right, so you see our same 1.7 volts. I'm going to reach down and unplug the TPS while maintaining my connection here. I'm not going to take my back probe tool out. We're just going to stay monitoring the TPS. Their TPS is now unplugged and I'm still at 1.7 volts. So what that means is it's not a shorted TPS. And what I want to do from this point, because I may have to do some short to ground tests with an ohm meter when I'm done, is as I unplug these sensors, I want to leave them unplugged so I can do further checks later in case I don't find a shorted sensor. So I'm going to leave that TPS unplugged. I'm going to go to the next easiest sensor, which in this case is the map sensor. The two transmission speed sensors are a little bit difficult to get to. We'll go to the map next. I'll get you a shot of where that's at and come back to the meter. Okay, you see our TPS to the right. You see I got that connectors unplugged. It's just kind of sitting there. And map sensor is down here. I'm not going to move my multimeter lead. I'm going to stay where I'm at on that yellow and red, even though the map has a yellow blue as the feed. Again, I said it's the same circuit. So I'm going to stay there. Focus you on the scope while I unplug the map sensor. Okay, back on the meter, you see I'm at 1.7 volts. I'm going to reach down and unplug the map sensor. As soon as I unplugged the map sensor, I actually heard the fuel pump run. I buried my scale here. I'm at 4.996. I'm going to take this and jump that up to a 10 volt so you can see it. And again, I'm measuring the 5-volt reference off the TPS while I have the map unplugged. And what this confirms is that we have a shorted map sensor. Our map sensor was pulling this 5-volt reference to ground, not all the way, but enough to interrupt not only the signal circuits for the sensors, but also that communication link. It uses that same 5-volt reference circuit for communication. This is the same stuff I have listed in, I believe it's section 10, the 5-volt reference circuit in my book, where we go through this procedure and we identify whether or not we have a shorted reference circuit causing our no start condition, and that's exactly what we had. Had we gone through spark and injection pulse and all that, we probably would have found that we didn't have any of those. I didn't check them because of our direction that we found right away. We didn't have this 5-volt reference, so we didn't go through all those steps. We got lucky in that the second sensor we unplugged was the shorted sensor. We didn't have to go to the transmission. But if you think about this logically, this does match an engine swap. When this engine was replaced, the TPS and the map, I'm sure, came with the junkyard engine. This car did run before and didn't run after it was installed, and it just so happened that we have a shorted map sensor that's pulling this whole circuit to ground. Now, the last thing I want to do is to see if the car actually runs, and I know it won't run great with the map sensor unplugged because it's a critical input, but I just want to see if the car starts. So I'm going to plug the TPS back in. And you see our 5 volts is being maintained there. That's good. I'll show you one more time plugging the map in, what it does to that 5-volt ref. As soon as you plug the map in, there you go, shorts the ref out. So that gives you a little bit of insight to how highly protected I think these reference circuits are. That it isn't just like a regular 5-volt regulator you buy from Radio Shack that you short it to ground and you kill it. They put protection circuits in here for this. These cars are designed to basically have issues and protect the computer. I think you're seeing that protection take place. So what I want to do is I'm going to shut the key off to kind of reset the computer for a couple of seconds, and I'll try to start it. Can I get one of you guys to do that for me, Jeff? Shut the key off.
All the way off?
Yeah, and give it like 5 seconds and then try to start it. Just wanted to power that computer down and give it a wake up when everything's alive and talking. Go ahead and try to start it. Very nice. Now this thing, again, won't run great with this map sensor unplugged, but that is a confirmed fix. Go ahead and shut that back off. Shorted 5-volt reference circuit. How important is it to know the process we went through when you see something like this? I think it was critical, and it's going to be, like I said, a great review for, I believe it's section 10, it might be section 9, that I have all this stuff listed down in order on how to do this. You don't see these often. The last couple that I did was a bad ground, bad power, but when you have a shorted sensor like this, man, it can really throw you for a loop. So, real good one. Hope you liked it.